So this is our lecture series 4, and what we have done previously we explored about classical versus Bayesian statistics, right? What's the main difference between classical and Bayesian? Is the difference of information, that is use of historical information to identify the problem, which is the Bayesian case. So in Bayesian case, we learned that we always, whenever we are identifying the problem, first we use the historical information, then we probe the problem, and then we probe the situation and then identify the problem. Whereas in classical statistics, um, we ignore that historical information. It means the use of probabilities. We in Bayesian we use the probabilities. We assign the probabilities of the past events or historical event. Okay, good. Uh, Then we discussed about functions and its type. There are major 4 types. That's linear, quadratic, exponential, and log function. These are really important functions. Um, we understood that what is function, the possible relationship can exist between 2 variables, y and x. Usually in y, for example, if y equal to f of x, what is the possible relationship? What is y? We call y is explained variable, which is explained by explanatory variable x. Oops, I think it's not working. Something happens. Sure. Okay, now I think it's working. So we can call x as a explanatory variable, which is explaining y. Y is also known as dependent variable. You can learn different names for y, dependent, and x is independent variable because it's defining independent, you know that, right? Then y is also known as endogenous variable, and x is exogenous variable. So y can be endogenous and x is exogenous variable. So there are different names. So we can say dependent, independent, and exogenous or endogenous. But anyway, you can use any name from them, from these names. But we know that x is independent variable. The major relationship can be defined in a straight line. So if I draw a linear function, it can be any straight line. It can be like this straight line. It can be like this straight line. Any straight line is a linear function that we have learned, right? So just like take, whereas quadratic has a U shape or inverse U shape, and with in a function this is with power or with order 2. So linear function is always with power 1. For example, a plus bx, whereas quadratic function is a plus bx, and we also have x square. So that's the main difference. Whereas in exponential function we have this kind of figure where it is asymptotic to x-axis. Asymptotic to x-axis means it never touches the x-axis. So it means this function is never 0, but it goes along. It can go along with x-axis in long run, right? So this is exponential function. That's how we draw, and log is the inverse of exponential function. So it means we can draw in this way. right? So here it can go asymptotically with the y-axis. So this goes asymptotically with x-axis, this goes asymptotically with y-axis. So we learned about different function in last week class. So today, this is really important. That's you already knew, and I'm sure that you have revised it. Today we're gonna talk about differential. So what is differential and what are the rules, we need to take care of during the differential? Then what are the how many orders we can differentiate, and what is partial differentiation, and what is integration? If we will have enough time, we will also touch matrices, that's features and definition, and what are the operation, because matrices are usually opted as an operation, that is addition, subtraction, multiplication, and division. Then we will also learn some properties of matrix, that what is the rank of matrix, what is inverse matrix, what are the trace matrix, what is the eigenvalues of matrix. So if we will have time, we will cover this in today's class, try to cover this in today's class, but last 10 minutes we will learn about e-views. So today we're gonna start the software which we're gonna use in our econometrics, regressions and different kind of estimations. So probably this week we will cover whole this scenario, and maybe we will touch probability in next class as well, but the probability gonna start from the next lesson. Now if we talk about differentials, what is differential? What is differential? Means, can you guess anything? Yeah, I can guess, because I can see some words originated, some word which can be extract from this word differential, and that is difference. Now, is it a difference? Is differential a difference? I will say yes. As the word itself, it means the difference, but we don't know. There might be many differences, but here through differential we capture only the difference within itself with respect to another variable with the difference within itself. That is a rate of change, right? So rate of change is also difference. For example, if x is this point and x2, x1 is this point and x2 is this point, so what's the difference here? So difference will be x2 minus x1, which we can also nominate as delta x, right? So that's the difference. So what is this difference? This is the rate of change in x. Similarly, we can have, this is on x-axis, right? Similarly, we can have y-axis. So if this is y1, this is y2, so we can have a rate of change of from y2 minus y1, which is equal y2 minus y1. So this rate, let me show you on the camera, so it will be easy. So from now onward, I'm gonna use the camera. Okay, hope you can see me. Yeah, you can see me now. So I have to readjust my system, means I mean my computer, in such a way so that you can completely see the camera. It's okay, you don't need to see me, you just need to see this whiteboard. And in the background there is some pink color. All right, so where's the marker? Here. So now you can see this now. Okay, so if we see, this is x-axis, this is y-axis. So this is one point, let's say this is one point which is x1, and this is another point which is x2. So this we call delta x. So delta x is the change of x2 minus x1, right? I can see this one. Similarly, we can have this one y1, right? And we can have this much y2. So we can have delta y, which is y2 minus y1, the change, the difference. And it seems like this is the difference, right? So this is delta y and this is delta x. Now the slope will show us the rate of change in y with respect to rate of change in x. Means how much change in x happened because of the change in y. So that is delta y upon delta x. So this is the basic theme of differential. Now, it's really important to understand. I hope you can see a little bit of me. Let me turn like this one in this way. Yeah. So what does that mean? For example, that means like this is you, kind of you. It's an example, okay? And you got a certificate which said that you are graduated. Now your life changes. This was before you, when you were in the when you were studying in exam and were very tired and everyday studies. Now you are happy because this is like you are studying. Right? So what happened? Now you are graduated. So there is a change in your life status. On the other hand, you have parents, right? You have such a nice parents who can give you everything to study. Now, when you were in this stage, they were worried that you should work hard, you should study hard, right? But now when you are in this stage, so there is a change in the status, because now they know that you're gonna earn money, you're gonna get a job, so they are a bit happy. So this change from worried to happy, and this change from study to graduation, so let's say this is delta x and let's say this is delta y. So how much change happened in your status impacts the change in your parents' status. This is known as differential. So in single word or in a single definition, can I write this? That the impact of rate of change in one variable on the impact of rate of change on another variable or in another variable. So that's how I can differentiate, I can define, right? Do you understand? See, it seems easy, not that difficult. Understand this, and then we can go forward. Now I can use the same graph or different graph to illustrate this one. So to be more, so that you can be more clear. Because this is the very basic, this is really important. So it means that if we have y equal function of x, this is our function, right? So it means this applies dy by dx equal d function of x upon dx. It can be shown with f prime x as well. right? So this can be shown as f prime x. So this is one time differentiation. Okay, now, and it's also called the derivative of order 1 or differentiation of order 1, means only one time differentiation. So whatever we get it, if we again derivative, then we can have two order derivative. If we again derivative, then we can have 3 order derivatives. So that's how we can go to higher orders. We will talk about this in few seconds, maybe after some few minutes, that what are the higher orders and what is the basic and why do we need. So now let's say we have a function, any function. Yeah, this is a function. And what is this? If it's a curve, so any curve, this is circle is also a curve, right? So any curve which touches any line which touches the boundary of the curve, that's known as tangent line. And any point which touches the tangent, that's a tangent point. So here, to get the slope, to get the rate of change mathematically, what we do, we draw a tangent. Oops. So let's say this is a tangent. Now, what is this? This is one point where it touches the function, where the tangent line is equal to the function. So this is f of x. So here, y equal to f of x, we define with x this, right? Now, if there is a change, and there is a change in x, so let's say if it's returning, because here it's going up, then it's going constant, then it's declining. So before declining, that's the highest point of x, means the highest change is possible here. So that's x2, that's x1. And can we draw this in such a way that in this will be our y2. This is y1, this is y2. And this is x1, which is also delta x, as I told you. And this will be delta y. So what is the slope? Delta y upon delta x, as I told you before, right? It means it is differentiable if this function f of x is differentiable if at point x, at any point x, if now for a time being, can I say limit delta x tends to 0? If this difference tends to 0, it goes towards 0, which means the function, this function will tend to f of x, right? So can I say this is so y equal f of x is here. So what is this? What will be the y here? So here, can I write this y equal to function of x plus delta x? Because actually x2 is delta x plus delta x. That's x2, right? Do you understand? x2 is x plus delta x. So can I say y equal to function of x plus delta x is this function? And y equal to f of x is this function. So the change in y, this is change in y, this one. So what is the change in y? Sorry, no equals. F of x plus delta x minus f of x divided by x plus delta x minus x, right? Which is delta x. You know, how did I do that? So it will be x plus delta x, which is x2 actually, minus x, which is x1 actually, right? So if I solve this, this will be cancelled, and I can just get delta x. So any function is differentiable if delta x tends to 0, and we have this one. Do you understand? So this is really, really important. You will know why it is important. So we call it this we call it dy by dx. We can also show it with function of f prime x. We can also show d function of x by dx. Right? So there you can have different notation by explaining this one. Do you understand? Have a look for, like, let's say a few seconds, and then we will pursue, we will move forward. Because this is important. All right. So try to repeat it. If it's possible, you can also take the picture of the whiteboard. It's better because then you don't focus. You will try to understand it. You don't need time to write it. Okay. You don't have time to write it actually. So what can I do? I can write this main formula, main theorem here. Limit delta x tends to 0. Here we have function of x plus delta x, that's y2, minus function of x, that's y1 or y, divided by change in x. That's our theorem. For our own ease to solve different, yeah, now it's better. Oops. Yeah. Now we have, based on this thing, I just nominate delta x as an epsilon. Right? So I can rewrite this one as epsilon. Epsilon means error, means also the difference. Can I write like this? Just to make it easier, rather than to write delta and then x. So this is the main theorem. Based on this, we can define different rules of differentiation, of differential. And here we will just have a quick proofs. Right? So remember this thing. Now our first rule is that if y equal function of x, which is constant means c, means any number, 1, 2, 3, 4, 5, any number, right? So we can say, if this is the situation, then dy by dx, which we also can we can give a notation of f of x, equal 0. How? Very simple. We know this thing, this limit, right? So if function of x equals c, then what is function of x plus error? Now x is already constant, so error is also a constant. So it means this is also a constant, right? Means any constant. So because x here is constant, so error is constant. So you put constant number into constant number, it gives you constant. Okay. So now just put the theorem, apply the theorem. So it means f of x prime can give us this one, c minus c upon epsilon, which is equal to 0. So hence we know this one. So you can also use dy by dx. So let's choose the same notation, dy by dx. Let's not use f prime x to make it easier. So that's rule number 1. Got it? Now, rule number 2, if y equals function of x, any function of x, which is equal cx plus d, means linear, right? So if the function is linear, then it applies dy by dx should be constant. How? Let's see. Same formula, same rule. You have function of x, cx plus d. So what will be the function of x plus r or epsilon? It will be cx plus epsilon plus d, right? Put it in the differential. dy by dx will be cx plus epsilon plus d minus cx plus d upon epsilon, which will give us cx plus c epsilon plus d minus cx minus d upon epsilon, and it will be cancelled. It will be cancelled. This will give 1, so it will give us the constant. So dy by dx is constant. So that's how we get rule number 3. So any function, any linear function, we know if there is a power of order 1, we know how to take the differential. So usually you have to know this, but I'm telling you that how did we reach this? So that, as I told you, concept is really important. You're not here to memorizing these rules. You should also know the concept, so that if anything can be changed a little, you will be able to solve it by yourself. Okay? Now, rule number, so you can have a look and then we will go further. Rule number 3, which is y equal function of x equal x square, which means any quadratic function, right? How to do that? How to deal with that? So this you noted down. So I'm gonna just remove this one. So if fx is x square, then x plus epsilon will be x plus epsilon square. So just put the theorem dy by dx. Let's make a race. Now you understand the procedure, right? Let's start together and let's see who finishes early. So minus x square upon e. So we know a plus b square. You have learned this in your high school, so I don't need to tell you. 2ab plus b square, right? This one. So just apply this here. So dy by dx will be x square plus 2x epsilon plus epsilon square minus x square upon epsilon, right? So this x square will be cancelled, and we can take epsilon, 2x plus epsilon upon epsilon. So this will be cancelled, so it will be given us 2x plus epsilon. Now remember, we said limit epsilon tends to 0. It means it's really small positive number which is really close to 0. But remember, it's not 0. It is close to 0. So we can just ignore it because it's an addition. So we can just ignore it. So it will give us dy by dx, 2x. So we can say that dy by dx will be 2x. So that's rule number 3. Now, based on the same phenomena, we can go for rule number 4. That is y equal function of x. And if we have x power n, so we can get dy by dx n x power n minus 1. How do we do that? The same thing. I'm sure you have noted this down. See, this is mathematics and a bit of mathematics, and it's kind of a fun. Once you know the base, you can extract anything. Now, this one is really important to understand. So this will be the difference. So what will be the dy by dx? X plus epsilon power n minus x power n upon epsilon. So can I write this function as x plus epsilon times x plus epsilon times so on n times x plus epsilon, right? So they are almost n times x plus, and then minus xn, this as it is, upon epsilon. Now, how to solve this one inside? Simple. What you need to do, look, this x is multiplying with x. How many times? N times. So I can write x power n, one function. Then I can write, then what will be the next? Because it's plus, so I will add plus, just like 2ab. So 2, how many times 2? So it will be n, right? Instead of here it's 2, so here it will be 2. So if here it's n, so here we get n, and then ab. So what is our a and b? So it's 1 less than n. So 1 is epsilon, which is b, and x power, because it's less than 2. So here it's 2, here it's 1. So here, if it's n, so it will be n minus 1. This is really important to understand, okay? How did we extract this? Based on this formula. And then we have many other terms, which includes, next term will be epsilon square, because if you know the formula of a plus b cubed, it's like a cubed plus 3a square b plus 3ab square, something like that, right? If I'm not wrong, plus b cubed. And so on, so on. So it's n. So next term will be something, something here, but with epsilon square, plus so on, something, something here with epsilon cubed. So there are a lot of terms like this. And then we have this one, x power n upon epsilon. Now, because we know epsilon tends to 0, so what is the square of epsilon tends to? Of course, it will be go further close to 0. You see, you can say, like, if say epsilon is 0.05, so what will be the epsilon square? It will be 0.000025, something like that. All right, so it goes further close to 0. So all these terms, can I say, because it's really close to 0, so I can consider all these terms as 0. And I can just take this one, because we have one also in denominator. So I can take x power n plus n e epsilon xn minus 1 minus x power n. This one is minus, remember? So this will be cancelled by epsilon. So epsilon, epsilon cancel. So what will this give us? N x power n minus 1, which is the same as we have the rule. Understand? Just have a look. Right? So we go ahead. Now we have some further rules. So I'm going to erase these first 4 rules, okay? And we will see what are the further rules. So what if we have a function in a root form, that is y equals f of x and root of x? So then we will have dy by dx equals 1 by 2 root of x. So this is a rule which you can remember, but how did we get this? Same thing. So if f of x equal to root x, which I can also write x power 1 by 2, and so f of x plus epsilon will be x plus epsilon power 1 by 2. So can I write dy by dx as x plus epsilon power 1 by 2 plus x power 1 by 2 upon epsilon? Yes, it can write like this. But here, we know another formula, which is a square minus b square, which is a plus b into a minus b, right? So here, it's really hard to open the root. So I can just multiply it by 1. How? In this way. So you have to be smart at how you can find out the solution. So this is actually 1, because this cancel out, it's 1. So nothing actually, I'm not doing anything extra. I'm just like playing with the numbers so that I can solve this one. Now the above equation can be solved. This is a, this is b, this is a, this is b, and they have plus. So a plus b, a minus b equals a square minus b square. So can I write x plus epsilon power half, and this is square, minus x power square upon epsilon, which gives us below the side half minus half. So this will cancel out, this will cancel out, this x will be cancelled with this x, this epsilon will be cancelled to this epsilon. This will give us 1 upon x plus epsilon half minus x half. Now we know here there is a one thing, that epsilon tends to 0, right? Oh, this is minus actually. So here we will do with the plus. Yeah, because this is minus. So now it's right. So here it's plus. So if epsilon gives tends to 0, so this will be the same function x. So can I write this 1 upon x plus x? So it will give me 1 upon 2 x 1 by 2, which can give me 1 upon 2 under root x, which is the same thing. So you can have a look. So that's our rule number 5, that if we have a function of a root of x. So you can say if we have a function of nth root of x, then dy by dx will be 1 upon n root of x. Just applying the same rule. Understand? Okay, I'm gonna erase the proofs. So you see, it's so simple. You just need to know the basic theorem. So hence, differentiation is the name of the operation. So it's like a machine where I put something into a differentiator. So this is a machine. I put function of x here, and it gives me function of f prime x. So I put y here, it gives me dy by dx here. So I put x square here, it gives me 2x here. So I give a root x here, it gives me 1 by 2 root x. So do you understand this? So that's how it works. So just consider that it's a machine where we put different function and output will be different formats. Okay. Now, what is the continuous function, any function. So this is continuous function, right? It's continuous, whereas this is broken function. This is non-continuous function. It's not like it's broken from many places, right? So this is continuous. This is non-continuous. So any differentiable function must be continuous function, or every differentiable function is a continuous function, right? How do we know that it is continuous or not? So if let's say function of x, we know fx prime or dy by dx equal to f of x plus error minus f of x upon error. So now we know that this error epsilon tends to 0. So can I say f of x plus epsilon equal to function of x, this I take there, plus epsilon I take here? Can I write like this? Yes, I can. It's really important thing. What is the important thing here? Because this function can be differentiable. Hence, f prime of x, some number, it is some number and it is countable here. So we can say that if epsilon tends to 0, this thing, this will be 0, right? If this tends to 0, so this will equals to f of x. So f of x plus epsilon, it tends to function of x. So the difference, if the difference tends to 0, the next y2 will move towards the y. So if this condition is there, then we can say that this is a continuous function. So now let's take some rules, some other rules. That's product rule, division rule, and some other rules. Sum of function, how we do sum of function, product function, subtraction of the functions, different function. We will see what I am talking about, right? So let me share the screen now. So you can see me here. Oops. Okay. Anyway, so now oops. So this we know. You know about this function, right? Y equal to function. So the rate of change in y can be noted as I told you this. So we already have done this. So remember this one. This is really important. So here epsilon means change of x. Okay, remember that. So first differential of order 1, this is first differential. You already knew that. I have done this. So now we have some fundamental derivatives. We know this one we know. This one we know, you know, this one you know, this one you know, this one you know now, and you know how to derive these, right? So next we're gonna talk about this one, that how we did that. And then we will talk about this function as well. This is not so difficult, this is really easy, especially if you know this one, right? So based on this theorem, we can derive any kind of differential, and then we will talk about chain rule and some different orders. and we will talk about this. So it will be easy. And if we have time, we will do this one. So now, right now, let's take a quick break of 7 to 10 minutes. And I will see you in at 5 past 8. Okay, 5 past 8.